This presentation on multi-level regression was prepared and presented by Christina, a health informatics graduate student at George Mason University, for a TeachOne assignment for HAP 823 taught by Professor Alemi. Multi-level regression allows us to examine the relationship between variables on two or more levels. It allows us to create two sets of regression models. Intercept regression will be used in this assignment. I'll be going through the steps to answer question 1 for week 4 as shown here. The question presented is as follows. The following simulated data show the survival of patients in 2 tertiary medical centers and 3 community hospitals. Should ambulances take trauma victims to tertiary medical centers, bypassing community hospitals? To answer this question, first we will predict patient survival rates using patient-level variables, presence of severe burns, head injury, more than 65 years old, and male gender. Second, we will regress unexplained variation in survival probability on features of the hospital, including whether it is a tertiary medical center or has a dedicated burn unit. Presented here is the CSV file that we will work with. Upon opening the data provided, you notice that column A is blank. In order to make it easier when running the regression in R, I delete the entire column so that all the columns shifted to the left. This ensures that there is no blank column when inputting into R. However, if you do not do this step, feel free to write an expression in R that will omit the first column. In working in R to answer this question, first I imported the CSV file into R and stored the file as data. The first line presented here shows how to do this. The second line of code shown here shows how to run the regression model. The dependent variable is probability of survival, and the independent variables are listed to the right of the squiggly line. Notice that in running this regression model, we have a categorical variable known as hospital. So we use the as.factor parentheses hospital to create factors that R will read as numeric variables. The third line will produce the regression output, which is shown on the next slide. The output of the regression model is shown here. Here you can see the intercept is 1.16225, which we will use in the next regression model. Based on the results, all the variables are statistically significant predictors of the probability of mortality. This includes the 5 hospitals, A through E. Now we will want to look at the effectiveness of each hospital by holding the patient characteristics. In the next slides, I will show how to do so. Here I created a table in Excel with 3 columns. The first titled Tertiary Center, the second titled Burn Center, and the third titled Different Intercept. Rows 2 to 6 represent hospitals A to E. The values for the first 2 columns were already provided. The different intercept for each hospital was derived from using the outcome intercept from the previous regression output. Each value was subtracted from 1.16225. After creating the table, CSV file was imported and stored as data too. The first line shows how to do so. The second line of code shows how to run the regression model. Different intercept is the dependent variable. The dot following the squiggly line is used in the formula to tell R to use all variables in the data. Again, the third line will produce the regression output, which is shown on the next slide. The output of the second regression model is shown here. In the residuals, you can see the results of each hospital. This regression shows that the hospitals with tertiary centers reduce the probability of mortality, and hospitals with burn centers increase the risk of mortality. That concludes my presentation. I hope you enjoyed it.